So to make a brief story about what's going on here, this is 8-inch PVC pipe that comes from under the ground. We're at a fountain south of Tampa here. The 8-inch pipe comes up from 2 grates that are down in the fountain on the other side of that waterfall. There's a bunker room here that those 8-inch pipes come through. That pipe's been cut. There was a check valve there. But as that 8-inch comes up, it made a loop over, down, and then to these 15 horsepower pumps. If you can see this pipe over here that looks melted, both pumps failed to prime on like a Tuesday morning. They heated up to the point that it melted and collapsed the pipe. We had other people look at it and go, oh, it's an implosion. And we called the guys at Speck, and they looked at the pictures and they go, your impeller just sat there and cooked and cooked and cooked till it created enough heat that in the pipe there it melted. So our plan is, the original creators of this fountain, there's a lot of really shoddy work here. We're gonna switch this 8-inch out to 6-inch. So then 6-inch is gonna come up out of these 2 guys, come straight over to our pumps, not go up, down, and make the loop to it. We're gonna replace the big check valve, the 8-inch in the basement there in the bunker room. These are not self-priming pumps, unfortunately. Whoever picked these pumps out, you know, if you're uphill, we're a little over 6 feet above water right here. If you're uphill like this, I know that right now this whole thing looks like the biggest shit show ever. But if you're 6 feet above water, you do not want centrifugal pumps like these. These are $10,000 a piece Speck pumps that are so problematic. And it's not that the pumps are bad, it's that they've been put in the worst place ever. So anyway, we're gonna replace all that and see how it goes. I'll try to make a time-lapse video of cutting all the pipe. So all the changes have been made. Instead of it coming up now and making this up and over trying to keep prime that was causing a lot of cavitation up in here, we just made the straight 90 that goes straight to the pump here at level. I haven't done the other side yet, so this is just an update. This was kind of to see what would work. But if you look down in my pump room here, the old pump room, you can picture this pipe, right, that's running right across there. That's the check valve right there. That's a 6-inch check valve that was put in. The old check valve that was there was leaking. And obviously since this goes, the water line down there goes up about 7 feet. So what was happening is when you shut the pump off, the check valve wasn't holding. The water from here was draining back down and coming back into the pond here. And then when the pump would fire up in the morning, the pump would fire up dry. So we replaced the check valve there, made the straight shot to the pump. If you listen to the pump now and see the pump basket, this is the best it's ever run. I've been around this pump now for about a year, and it's always vibrating. There's always air bubbles. This right here, it's running like a champ right now. I couldn't be happier with it. So I brought in this feeder hose off the cleaning pump over there to constantly give it a little bit of water, that if it ever did run dry again, it wouldn't cavitate and then melt all the pipe. I've got this little auto bleeder valve, so when you do take the top off, as you're filling it with this hose, it'll release the air out of there. In this submersed flooded suction pump, you cannot have more than about 10% air in that chamber. What really changes everything in this system though is because we're 10 feet up on the hill here in a flooded suction pump, you can imagine that the positive side coming out of this that comes down, when you turn this pump off, what was happening was the siphon out of here that's going downhill and going all the way down into the fountain, it was pulling so hard. It wasn't pulling hard enough though to pull the water behind it from that check valve that I just showed you down in the ground there. but you get this small air pocket in here. This suction on that siphon would pull all the water down, and you get this little bit of air that's trapped in here, and it was just enough that when the pump fired up in the morning, it wouldn't be able to complete the circuit and fire up. So probably the biggest change in the pump is this anti-siphon valve. So this is on the positive side coming out of here. The anti-siphon valve then, instead of it sitting there pulling and creating all this negative pressure in this pump, that siphon valve, when you turn it off now, like I'll turn it off and you can listen to what's happening here. So I go to my timer here, kill the pump. Hear that? So see how my pump is staying 100% full? It's actually overflowing right now because the water flowing back into it. So you can imagine this is as at 9 o'clock tonight when the pump turns off. Before I had this anti-siphon valve though, what it would do, see now I'm actually running water over. Before, what it would do though, it would sit here and this siphon would actually pull all this pressure out of there. It was a huge problem. But let me kick it back on here. And this is how nice this fire's back on. Before, when you turned this pump off and let any air fill in it whatsoever, it was completely hosed. So now it's just running like a top, man. I couldn't be happier with it. This, I'll just show you in this. This is from the other pump here. This is now our backup pump since I've got an aerator versus the old fountain pump running. So when this pump does wear out, this guy is just going to take his place. This guy had a leak in the body here. It was creating all kinds of problems, you know, with this being uphill, and it's got so much negative pressure on this side. Any leak in it whatsoever is just a disaster. This is coming out of my cleaning pump and just feeding a little bit of water into there. So that way, if it ever does run dry, it doesn't completely destroy itself. My cleaning pump, again, this is 8 feet above water. His check valve is right there. That needs to be replaced, but as of right now, this guy is on a timer. He's kicking on and off. The whole system's running way better. But the big change is the check valve, the anti-siphon. Those two things are killing it, absolutely killing it. I'm trying to think of something else, but if you just can't imagine the experimentation that went on here and thinking the intake was 8-inch before, it's been now reduced to 6-inch. That's how big the collar is on this pump, is 6-inch. But trying to pull an 8-inch tube uphill, you can see that's the old 8-inch right there. Almost impossible. Any air in there whatsoever, and just the whole thing is lost. But it's running good now. I still don't know about the up loop that the engineering company put in it, trying to maintain prime, because it seemed to just like get air trapped in there and it was cavitating. But this has been a really long process to get it to run good. So hopefully we get a good amount of time off this. Hopefully it runs for 10 years, we hope. But this thing has been such a disappointment to me that this pump room, because it's under the water line, floods all the time. The sump pump in that corner failed. You just can't believe the series of problems. All the electrical has been removed from down there because it's now just that's the old pump, the old trash pump, that because the pumps were down here, like I explained in the other video, they were moved up here. But if you want to see, there's 4 huge waterfalls running off that pump. So that's 2 of them right there, and there's 2 more on the other side. I don't want to film it but trying to put a flooded suction pump 10 feet above water like it is and get it to work A friend of mine's an engineer. He came and looked at all this and said, well, you know, you've got the wrong pump for the job, and I totally agree with him. Would I rather have a self-priming? I would, but right now things seem to be running great. I just wanted to make a film of this in case somebody else is running into similar problems with siphon and negative pressure and check valves. If you have a good working check valve, all your seals on your pump and your pipe obviously are good. An anti-siphon valve to let that pressure out. That's all the things I've learned from this. And if I could add one more thing to this video, because it's a flooded suction pump, the lid is not designed to have real suction on it. You know, it's supposed to just be a gravity-fed pump. So when they designed the lid, this is the lid to it, they just put this bottom gasket on here. This gasket here is off of a Pentair filter, like, you know, your typical cartridge filter from Pentair. I believe it's like a 15-inch. So when it had this gasket on here, when it gets that much vacuum suction on it from pulling the water uphill, it would actually let air pass by this. So one of the first things we did that, you know, was a huge help, maybe helped by 50%, is put this Pentair gasket on here, because this is the factory one. This is one just off the Pentair, this one that I'm touching here, the upper one. But this seals in there against that pump housing and doesn't let any air through. If you get any air passing through that lid, just the whole thing is over with. It just ruins the whole circuit. You can't keep it primed, but I just wanted to show you. And then you can imagine this poor lid. This is a faucet that I added, so that way I've got some water constantly peeing into that pump just in case it did run dry. My impeller, the impeller's $1,000 when it explodes in there from cavitation heat. So that's all that is. This is not meant to really do anything but keep a backup to prevent it from melting. I just wanted to show you this second gasket though. So I actually think this first gasket's doing nothing. This guy's doing all the work, but it sucks that lid down so hard you can't believe it.